Okay. We're going to solve quadratics, but brief review first, so I can get this in writing here. If you're finding the vertex, you all just told me why do we find the vertex? Okay, so we can find the maximum or minimum. And what two ways do you now know how to find the vertex? What two ways do we find the vertex? Yes. If it's in vertex form, then we knew it was at H and K. If it was in standard form, how did we do it? That's better, yes. We did negative P over 2A, and to find Y, we subbed in the x-coordinate. That can't go away, ever. You can't lose that. But now we want to solve. That's a different thing. This is finding the maximum point on the parabola. Now I want to solve the parabola. You're actually, in the next 3 classes, you're going to get 4 ways for doing this. Today, we're going to solve them by factoring. And since this is a really crucial skill, that's mostly all we're doing today. Okay, then next class, I will also show you how you can solve them by graphing. But for us to do that, we will be doing it with calculator graphing. So you definitely want a calculator next class. And then a method you have not seen before, at least I don't think you have, completing the square. Okay, that's one I had dropped because you actually won't use it that frequently to solve. There's quicker ways to solve, but it is something we run into later on. But with the new Common Core standards, for some reason, they're really pushing it, so we're bringing it back. And then last but not least, some of you may remember having once learned the quadratic formula. So those will be eventually our 4 methods for solving quadratics. But actually, my bigger concern today is just getting you really good at factoring. Okay, how many of us love to factor? How many of us thought factoring was the worst thing we did in Algebra 1? Okay. Well, not too many votes either way. By the end of this block, you will be aces at it. Actually, by the time you've done this and done your homework, you'll be aces at it. So, okay, I've taken you back to the basic stuff. Before I can teach you to solve by factoring, I got you to get you to realize what it is you're doing when you FOIL. So we're going to FOIL something real fast. If I gave you that to FOIL, okay, we've been FOILing for several times here. What do I get when I FOIL it? Okay, 2x squared. Okay, so outers would be negative 7 and then plus 6x, and then a 3 times 7 would be a minus 21. You can always combine what then? The middle terms always add together. Okay. So in the land of FOIL, the 2x squared comes from which part? It's the first. And the negative 21 comes from the last. Where did that negative x in the middle come from? It's the O and I combined. The outers plus the inners have to make the middle term. And when you're trying to factor, getting the factors to work to make that middle term, that's your problem. So we got to realize that to get the factors to work, it's the outers and the inners you got to get to make that middle number. Factoring by this method is nothing more, it's trial and error. It's just kind of playing with it. The more you do it, the better you get at it, because you get intuition about, oh, this will probably work, and you get much faster. But it just takes practice to get good at factoring. So what you're you're going to see, though, is I'm going to give you a quadratic. In this case, I'm going to say it equals 63. What do you suppose you need to do before you ever start trying to solve it? You have to get to 63 over. Anything, this is true for any equation with a power on it, x squared, cubed, whatever. If you're trying to solve an equation, you have to always have it equal to 0. The only time you don't, if it's x to the first power. Everything else you'll ever do in math, you always get it equal to 0. So, and the other thing you want to do with quadratics, it'll make your life 50 times easier. I believe we forgot to change the bells. Oops. The other thing that you always want to do is you want to keep your x squared positive. Okay, so the rules you learned about whether to put pluses or minuses in your factors, those all assume that x squared is positive. If you have x squared as negative, all your rules you know about pluses and minuses go out the window. So it's always easier to keep x squared, move it to the side that will be positive. So I'm leaving it here, and I'm bringing over the 63. And so then you're going to look at it and go, hey, wow, it's a quadratic in standard form, 3 terms. I can factor this puppy. So the firsts have to make x squared. So what do they have to be? It's got to be x times x to make the x squared. Okay. Don't put your signs in till the end. Okay. A lot of times in Algebra 1, we spoil you by always giving you terms that have a 1x squared, in which case you can put your signs in first and make it work. But if I make that a 2x squared or a 3x squared or a 5x squared, it will mess it up. You won't know where your signs go. So get in the habit of not putting your signs in first. In this case, the last have to make negative 63. So what are factors that make 63? Okay. Chances are good. Those are smaller numbers at 7, 9, but it could be 3 and 21. 63 and 1, yeah. Occasionally it's those obscure factors we don't think about. But looking at this one with a 2 in the middle, I'm kind of going, yeah, 7 and 9 looks like it's got potential. It does not matter which one you write first or second. Okay, now here's where I need to check if you remember your rules about signs. If this has got to be a negative 63, what do you know about what the signs have to be? Yeah, to multiply to make a negative, one has to be positive and one has to be negative. So we know that's going to happen. And until you get good at this, I teach factoring like this. Make your smiley face. Okay, you got the inner side part here is a 7x. Your outside is your 9x. Which one needs to be positive? Which one needs to be negative? So I'm going to end up with positive 2 in the middle. Yeah, I need a positive 9 and a negative 7 to make a positive 2. So therefore, since I need a negative 7, that means the negative has to be up here with the 7, and the positive 9 has to be back here. And so you should be able to check it. Yep, 9x, negative 7x, makes 2x in the middle. Now, are you done? Have you actually solved for x? Yeah. And this is those properties I don't have to drive you crazy with anymore. If you remember what you do with the factors just to get it solved. You set them equal to 0. The question is, why? Why does that work? Why is that? I just take them and set them equal to 0 because it's fun? Well, it's actually, if you remember the zero products property you had to learn for the assessments. But I don't care that you know the property name. If you have 2 quantities here being multiplied, your 2 factors are got to multiply to make 0. If you have 2 numbers that have to multiply to equal 0, what does one of them have to be? When you multiply to get a 0, one of the numbers has to be a 0, doesn't it? So therefore, one of these 2 factors has to equal 0 to make this come out to be 0. So that's why we take each one and set it equal to 0, because it could be, in this case, if I add 7 over, if I put 7 in there, it's going to make this come out to be 0. Or if I put negative 9 in there, it's going to come out to be 0. And so you should expect to get 2 answers on just about every single problem that are going to get you a 0 in the end. So question. I always have people do this, not now, but later on in the year. You're solving some problem, and you got it factored, x plus 4 and x minus 11, and it's equal to 13. Is it legal to go, oh, x plus 4 must equal 13, and x minus 11 must equal 13? Can I do the same thing with a different number? No. Because are you guaranteed that if you figure out what makes this equal 13, that when I multiply them, I'm going to get 13? No. It's only because 0 times any number is 0. That's the way it works. You cannot do this. If you're not equal to 0, you cannot set factors equal to something. This is a no, don't do it. But occasionally, later on in the year, I have somebody who goes kind of mildly crazy and tries it. You cannot do that. It only works if you're equal to 0. So is that horribly difficult to solve? Not so far. Okay. Usually what bugs most people when we start solving like this is if there's another number on x squared other than 1. That's where our issues tend to come into play. So if I give you 2x squared equals 7x plus 15, you look at it and go, no problem, it's quadratic. What should I do to it first? I need it equal to 0. Why not just move the 2x squared over? Just one term. Then it'll be negative, and we don't want a negative. So you leave that 2x squared over here where it is happily positive, and you'll just have to move the others over, which means they change sign. Then we're going to go, great, it's a trinomial. 3 terms, I can unfoil this puppy. What has to go up front to make 2x squared? You've got to have a 2x and a 2x and an x. Go right, your choice. What factors of 15 do you want to try? 5 and 3, 1 and 15. They both kind of look like they have potential. 5 and 3? Okay, and I want to teach you, when I say trial and error, literally. Okay, you think it might be 5 and 3. I wanted that to be another color. If you think it's going to be 5 and 3, just start checking. 5x, outsides are 6x. Is there any way I'm going to get a 7? It can't. So switch it. You always, maybe they go the other way. Maybe it goes 3 over on the left, 5 on the right. Now I have 3x and 10x. Could 3x and 10x possibly make a 7? Okay, now then check your signs. I need a negative 15. So what's that mean I know about my signs? One's negative, one's positive. So which one would you want which way? Yeah, because you would want your negative 10, so that means the 5 back here becomes negative. You would need a positive 3, which means we're up front. We have a positive 3. And then last but not least, what do you do with your factors? Sometimes we get too busy factoring and we forget to finish the problem. Yeah, we need to set it equal to 0 and solve it. And so when you move that over, you're going to, and by the way, I'm perfectly fine if you can look at these and solve them in your head. So that's going to be subtract 3, divide by 2, and that's, whoops, not y, that's an x, equals 5. And there are my 2 wonderful answers. Okay, it's the 15-minute pause.